Hello, welcome to the next session for this week. What we have done so far is created this kind of screen, and if you now try to register, as we saw, it shows the registered users. Our next step is to try to register a user from the browser instead, which is what we normally want to do. But changing the database and dealing with user input changes, etc., brings up several new issues. For one thing, every time you register a user, you have to say, have I registered before, and find some way of checking it and telling the user that such a username already exists, and so they should choose something new. Similar issues arise when you try to enter expenses. If you add or delete, if you add an extra expense or an incorrect expense, then you need to change it, and so forth. So to do this, what we are going to do is to use a combination of database facilities plus changes to the app, as we spoke of the last time we looked at this. So let's get started. First of all, let's take a look at what is needed to make changes to the database. This is our simple test program, InsertDB, where we are going to try to insert things into the database. These things are standard SQL includes as usual, and then this is our NPTEL user, NPTEL password, etc. Then the connection and statement and those kinds of objects. Here we have this simple-minded way of getting the driver. We mention the driver class and then load it. Then you get the connection, create a statement, and then try this out. What is interesting about it is the statement execute update thing is the same as what we have been doing so far. But the novelty is that we know that errors might arise, and so we need this kind of catch exception, which gets a lot of information from the standard SQL exception object. So it has a message, it has a SQL state, a error code, and a get cause. All of these are meaningful. The state in particular is what is called SQL state, and SQL state is actually a SQL language standard. And if you go on the net to look at these things, you will find a long list of discussions like mapping MySQL error numbers to SQL state code and so on. And the particular error number that we will encounter is called 42S02, which is, we know this is going to happen, so I'm just letting you know beforehand. The idea is that when you try these kinds of codes out, you should understand how to figure out what the issue is, and is it something we should act on, or is it something that the app should merely log and keep going. In this case, what we are going to do is print out the message, then close the database overall and stop. This is just a test program. So let's try it out. What we have is, so we do our usual Java C insert-db and Java insert-db.class, and as soon as we run it, we get this error message. What it says is that this particular table doesn't exist because we haven't created it yet. But this is the part that I want you to focus on. This is the interesting bits about the error. So the message and all is of course a normal text message, but the state, like I said, is a standard from SQL, and then MariaDB/MySQL also have these status codes that explain what is going on. And then you know what to do when errors like this arise. Now in this particular case, what to do is pretty straightforward. We have our setup code, and here we are going to create a table, but this time I'm going to create a table called users2, which we will experiment with, and then go back to our normal user table. So I have this thing. Now I will go to my SQL and paste it. So a table got created, describe users2, and so on. And right now there is nothing in it. But as soon as we create this table, at least we get something useful that comes out of it. So now if I try to do insert db, then the return value is 1 and the insertion must have been done. So let's try that out. Select star from users2, and we see that some name which we said is in the program here got inserted. What we now want to do is to make sure that you cannot enter the same username. And the way you do that in a database is to use what is called a unique constraint. Just like primary keys are required to be unique, we can also require that the username, the thing shown over here, is also, let me maybe make this a little bit bigger, so the font, yeah. So let's make this a bit shorter, and then here we are. So just like there is this primary key and that is unique, we can also make username be unique. And in that case, if you try to insert that same name again, this thing will tell you that you cannot do that. Let's see how that gets done. Since we have already created a table, what we can do is to alter this table by adding a constraint which makes the username unique. So if you do this, then it says that the table has been changed. And now if you see describe, what it shows you is that there is a key and there is a uniqueness constraint here. And now if we attempt to insert the same thing, as you can see, it says that there is an exception, which is that the duplicate key F1 is entered for uname. And this time the status code changes. It says it's 23,000 and then the MariaDB code is 1062. Let's just verify that that is indeed what we want. So here we have ER dupe entry and the SQL standard is 23,000 is the standard error code. So basically what we have learned is that in JDBC, if you examine the standard SQL state or the MariaDB code as the case may be, then you can use that to detect that a duplicate entry has been made. And if a duplicate entry has been made, we simply will not allow that. As we all know, when we use websites, almost all of them require you to register and identify yourselves, because no other piece of information like name, city, etc. Is necessarily unique, or also the case that somebody might easily impersonate you knowing your details. So instead we rely typically either you create a new identity or you use an identity which is already known to be unique, such as somebody's, say, Yahoo email address, where somebody else like Yahoo or Google have taken care to make that whatever it is unique. And after that you can say that at the very least I can detect that whatever I have is unique. And at that point you have a stable notion of user identity as far as your app is concerned, at least. So that's one part of the story. In the previous code, we created a table without a unique constraint and then added it by altering it. The alternative is to use this unique declaration right in the schema of the table. And that, to test it out, we will verify that what we get with this is the same as what the standard thing gives you. So we have created this table if you look at describe users 3, then you will see that the key is indicated as unique, which is a very similar description to that of users 2. These alternative syntaxes exist in SQL for one reason or another, and in particular, you can always change characteristics of existing tables, and that this ability to use tables to describe everything also applies to the systems within SQL itself. So for example, if you want to see how this uniqueness is achieved, you can look at something like this. So you can say show indexes from users 2, which tells you that it has a number of different indexes that are used to arrive to give this ability to have unique contents. Similarly, show indexes from users 3 also shows you how it is that the uniqueness is actually achieved. So that's as far as the database side is concerned. And here we saw that on the MariaDB side, by detecting the status code, you can detect that duplicate entries are going to get made. Now the next part is on the web side. After you have detected the entry, how is it that we can show the user that they have made an error? And for that, what we will do is our old idea of taking this page called register, which is over here. So JSP register, and currently the register page has no place for errors. It is just this kind of a simple page. When we look at this register page, what we see is the page that we have created, and the right place of where to return an error like this is a matter of UI design. For now, we will use a simple idea and arrange to place the error over here. Again, here we need to, because you need to show the error in this position, we need to change the page, and what we are going to do is something like this. In the register page itself, we have just the input field, which corresponds to the input field shown here. But in the register error page, what we will do is add another row besides the input field. So here we have the input field, and here there is a error message. A designer's question for situations like this is, for example, should the error message be centered or should it be aligned to the left hand side of the input field? All these effects, of course, can be achieved, but it gets somewhat ugly to achieve all this, especially just with tables. You can do much better with CSS, but again, that needs a lot more knowledge of CSS than we currently. To see the distinction, consider the error page we just created with a simple centered error message versus another page where we have taken care of the alignment of the left edge of the input field and the alignment of that with the beginning of the error message. But the code that does this is significantly more complicated, because what I have done here is to put a table inside a table. To get with CSS, you don't have to do this, but my point is to just show that even with tables, you could actually achieve them. To see what the change in the structure is, I'm going to show you a useful trick that can be used to see exactly what components in the sense of what are the nodes in the DOM that exist in this page, and exactly how is it that they are laid out. So what we will do for that is to edit this and use something called outlines. So what you can do is, for what this says is, for every single component, create an outline which is, say, 1 pixel solid blue, and then an outline gets shown which shows you what the structure here looks like. As we know, the primary part of the structure is a row of buttons, a row with the input field, but then this input field in turn actually consists of a table which itself contains the input field plus the error message. And doing this plus sizing all of these things, etc., does tend to get somewhat painful. And the methods I have used, like using this center tag and so forth, are considered by modern designers to be less than elegant. They would prefer more CSS centric methods, and they are right. Going forward, CSS does make it a lot easier to create applications which work for mobiles as well as tablets as well as normal websites. But in a starting app, you can always do things like this. So here what we have is, we have one table which is the table outside that is currently highlighted, and we have another table which is the inner table that helps you align those two places. In comparison, if you go to this if you go to the previous design and do the same trick, which is to go to the style section and add an outline. So outline 1px solid blue. Then as you can see, the structure is a lot simpler. We have simply added an additional row. You could produce the alignment by carefully figuring out exactly how the first row with the input field is structured. But we are going to stay simple and just add another row to show the error message. So as you can see, as soon as errors enter the picture, the behavior changes not only in the database and that side of the game, but also the user interface gets affected, and the user interface becomes in some sense more dynamic. That is, you have to detect the presence or absence of errors and output different HTML one way or another. Now let us see what all this looks like in a working application. So I have already put it in the code, and then we will take a look at it later. So what I'm going to do is, I'm going to create a new user called ABC1, and as you can see, we have made a few changes. Instead of the C time being this arbitrary time that I was using before, now I'm formatting this like a normal readable time. The user ID is getting created as usual by auto increment, and this is the uname. If I take another one of these and register, I get this, and the list is sorted in a descending way. So what you have is the last registered thing shows up first. All of this is done using SQL, and if you are familiar with it, you can see it. Otherwise, I will show you the queries in a little while. Now let's try to create some duplicate input. So let's try creating ABC2, and now it says ABC2 already exists, see below. So the round trip to the database gets made, the presence of ABC2 is detected, and you get the error back. Of course, if you put ABC3 and register that, there is no issue. ABC3 happily gets registered. In this way, our basic functionality of being able to register users and detect duplicates is done. What you will find though is that complications keep on coming up. Before we look at some complications, let us see what the code for this thing looks like. Okay, What we have now is that, remember from last time, that when we get one of these parameters, button register, button expense, we note it over here, and then we have a if statement that just says, what am I being asked to do? I'm going to do it. And the structure is, you get the request dispatcher from register. And this time what we are going to do is two things. First, the update part is done in a function called register user, which takes the request and the output. This output is the print writer, which we get from the response as usual, and that is what we will write to. Then we are going to get all the registered users, the query part, and this is included in the template as we have seen before. Okay, so let's go to register user. There we are. So register user is over here, and let's see what it looks like. So first of all, there is the servlet request, there is the print writer, and here what we do is, from the connection we create a statement. We get the username that the user is supposed to have supplied. We check whether it is null or not, and if it isn't null, then you create this statement. You say insert into users ctime and uname with values, this time containing the Unix timestamp. This Unix timestamp etc. will be the timestamp that gets evaluated on the server side. This is a SQL function, Unix timestamp. And then you put in the username followed by the end of the statement. When you execute the update here, it tells you how many rows were affected. For now, we don't really care about that, so we are going to ignore it. What is interesting is what happens when we get an exception. Here, what we have is, we will get the SQL state as we discussed before. We know that we are trying to check for a dupe. So the dupe is in this case 23,000. And if the SQL state string equals this dupe, then we are going to do two things. We are going to set an attribute in the request that says, yes, there is a duplicate user. And which user it is, that also we are going to send, so that the error message can contain what user exactly was duplicated. If the SQL state is not this one, if it is something else, then on the other hand, we are simply going to dump the SQL exception and then close the statement. So it is only for this particular state that we are going to take action with the error. If not, we are going to do a SQL exception dump. And then no matter what happens, the next step is going to be all registered users. So we have all registered users, which now is a somewhat more elaborate query. So the query is select user ID and then take the Unix time that was stored, but format it properly. That is what the from Unix time function does. Call that thing ctime, because remember, ctime is what our template calls it. What I mean by that is, the register.jsp template has this variable here, ctime, and so you cannot change the name that under which the SQL results are returned. Get it from users, and then we order it by ctime descending, and that is what gives us this ability to get a list of users in the inverse order in which they were registered. That's what the order by ctime is doing for us. And then this is the normal sort of thing. So you do the query, get it as a list of maps, set the user data attribute, and go to the register JSP function. One novelty in here is that this template does two different things based on whether there was a duplicate user or not. As we saw, the goal is to add a row containing the error message only if there is a duplicate user, and if there is such a user, then you should mention what this is. So the cif is like C for each, one of those things from the tag library. So statement not too different from what happens in a programming language. And here you can say if dup user is equal to yes, then do this. Of course, if dup user is not present at all, then this entire statement won't get executed. And if it is there, then again set this thing with username, input user, etc., already exists. The other thing to notice here is, let's try this out. So I'm going to try ABC3 again, and it says error username, but in this particular format. So it isn't plain text, it is red colored text, and the input user we have already mentioned there. And how we got all this color, etc., is another use of a CSS class. This time the class is td error. Here are the classes that we use. So this is td/th that we have seen before, and here are where the classes. So this is td error. It says the color should be red, font style is italic, font size is larger, so just larger than whatever default font, and then align it in the center so it's clearly visible. The earlier classes th, top and bottom, were classes that we used here in order to get the table layout from last time. And so if there is an error, this row gets added. If not, there is no error row there. Okay, so far so good. But as I said, once errors enter the picture, all sorts of interesting things start happening, because validation starts becoming very important. And so here is a behavior that we would find unusual. Although the example so far, we have done the entry of input so smoothly that we haven't recognized that something strange might happen. So now I'm going to have no input here. And remember, I was testing for username not equal to null. And if there is no username, my intent is if there is no username here, then there is no need to do all this, right? It's only makes sense if a username is given. And of course, we can see all the users no matter whether or not you enter the username. So far, so good. But look at what happens. So I hit register, and interestingly, I got a blank name. What happened was, of course, that the field we got here was not absent. The field was there, but it came in as an empty string, and that is not something we have checked for. Interestingly, if you do this, let's see what happens here. So I'm going to do this again. It actually detects that the empty string is already present, and so the error behavior is correct. Let's take a look at what gets sent as the body. So here the parameter the field is sent to an empty string, but the parameter does get sent. So this is an example of how validation of user input is never a simple thing. There are all sorts of strange cases that we have to look out for. And typically you do this by separating out the entire business of user validation or any input validation, in short, under a different module whose job is to do lots of interesting things related to user validation. There is much more to it, to user validation, than the simple example. And I will show you another situation where that arises if you do not validate the input. So let's see what happens. What we have to do first is to make a change so that we reject the empty string. So let's do that first. Here the answer is, of course, relatively simple. Username equals empty, and if that's not the case, then we should ignore this situation. So that is what we are going to do. I made this change and compiled it, copied it, created the jar file as usual, and then deployed it in the manager. Now let's start. And this time, if I just keep pressing register, nothing happens. Of course, the old username is there. This time we are not going to make any change to the application itself, but we can go to the database and delete it kind of by hand. The deletion we do like this. So delete from, this is one of those things you can pick up. Delete from users, where user ID equals 30. There we go. So we have cleaned up our table. And now if we go to this thing and hit register again to get a list, the cleaned up list shows up. But that should remind us of something else. So here is one other thing we can try. We will delete every single row in users and make sure that nothing fails when the table is empty. So fair enough, the table is empty. And now we can register and things work as usual. So ABC2, we get an error. ABC3, things are working. This is fine so far, but you can imagine from this that testing, once you have a database, you should be able to automate this thing. And doing automated testing is one of the what shall we say, a characteristic feature of modern web development, where most of these things are tested in some version, some way to automate all of this. And in our case, we could use, for instance, embedded Tomcat, etc. But there are many ways to automate these things. The bottom line is, once changing and entering and checking the details starts becoming a feature of your application, life does get considerably harder. Here is continuing the same theme of difficulties with input. Let's try something else. So I'm going to create a new thing, but I'm going to end this input with a single quote. Now see what happens. Basically, the system has failed, right? It as we told it to, it basically dumped this entire SQL exception and told us a bunch of things about what just happened. And here is the issue. So what it says is SQL syntax error exception near ABC4 and something got completed. And basically somehow we managed to destroy the SQL statement, right, merely by adding bad input. And we know here what the issue is. See, if you look very carefully at this, there is a single quote here which serves to quote the username that we have given. And for example, if your name is ABC4, then this SQL statement is going to look like insert into users ctime uname values ABC4. This is what would have happened, correct, if the expectation, so the Unix timestamp followed by quote ABC4 and the semicolon. But because the name that you gave had a quote, there was an extra quote. It's as if this kind of statement occurred where an extra quote was present, and this is incorrect SQL syntax. This example is another case of user validation, but actually you cannot solve this merely with user validation, because there are enough, let's say, strange requirements of the input languages of these various systems that it is never safe to assume that you can write code that will decide what is right and what is wrong. The solution here is to not rely on this kind of string interpolation at all. In the worst case, such kind of string interpolation can actually result in hackers being able to take control of your database. So what we do instead is to use prepared statements. There are many reasons to use prepared statements. Sometimes under certain circumstances they can be more efficient as well, especially when used in loops. But it's not just that either. It is also the case that prepared statements tell the database which part of the statement is given by you and which part is coming as input from the users, so that the database will treat it not as something that whose syntax the database has to understand. It will cleanly isolate user input and then store it separately without letting it affect the rest of the statement. In our example, nothing is irretrievably broken. Only this request gets affected by what just happened. And if you happen to hit the input again, you are back to normal. The effect of that previous request was nothing that would span multiple requests and destroy the entire application. But of course, in some cases that can happen too. Let's see what happens when we use a prepared statement. Here's what we are going to do. Our code used to look like this, and we would have a statement and execute update with it by providing the query. The difference now is, first we are going to, instead of creating just a statement, we are going to create a prepared statement, and that at the time you create the prepared statement, you have to supply the query. The database actually, a prepare statement call will contact the database, compile the prepared statement. This is another reason, because of pre-compilation, that prepared statements can be more efficient. And in the prepared statement, we are going to leave a hole, a parameter where the user value will be plugged in. The usual way to do that is to have a question mark to say that this is where we are going to plug in a value. The rest remains the same as before. And then here is where we plug it in. So you get the username as before, you complete your validation, and then you do this. You say set string 1, username. And this time, because the query is already known, all you have to do is execute the update. Now with this change, the application, let's feed again ABC4 with a code and see what happens. As you can see, nothing failed, and in fact ABC4 with a quote appeared in the database. So do you want usernames with quotes in them? That's up to you. And so that kind of user validation where you say what you want, the idea is you don't say what is bad, you just say what is good. The correct format, the expected format is a set that you can narrow on your own. And the prepared statement means that whatever the input you get, even if it is something that the database, the standard SQL might not be happy with, when written down in a string syntax, actually it is a perfectly valid string or whatever other kind of data point you have. So if you are okay with quotes, then this is fine. Otherwise, you may have to decide that I'm going to only allow a certain set, and if what the user gives does not fit those things, then you should reject it there and then and show an error message like we did for ordinary registration. And then you can use the same idea, for example, for expenses and so on. And at this point, we will actually have nearly a full database app in which the only thing that is different is that different users cannot access the system at the same time just yet, not in the usual sense that if I am a user, I am able to put in my expenses, but I cannot put in expenses on somebody else's name. That is something we haven't done yet. But we can also, of course, do other things like making expenses and being able to delete them and so on. I'll do that, and then we'll take a look at what is needed. Not much is different because after all, it's the same kind of thing that you have to get the input, you have to update it in the database, make sure that the timestamps and everything makes sense. And at that point, you have a reasonably complete app. The one thing we don't have, for example, is various kind of delete operations such as remove a user and so on. If we get time, I'll show you how to do that. But in principle, it is no different from what we have done so far. Just as we did register, you could have another button called unregister. And when you give the user name, the system can delete the row from the database. So we are almost there. Once we add login and cookies, our app will essentially be complete. And you will have seen all the pieces, including various debugging scenarios that show up when a web app has to be developed. Okay, see you next time.